Hello, pre-algebra students. Mr. Lawrence here with your flipped lesson. We are learning how to multiply and divide numbers in scientific notation. And I'm telling you, this is really, really easy stuff. You just have to know how to count and how to multiply. But before we do, I want to ask you a question. If you had 10 to the fourth times 10 to the second, would you know what that equals? Well, the long way of doing it would be to say, what does 10 to the fourth mean? And I'll bet you that Michael can tell me that 10 to the fourth means 10 times 10 times 10 times 10. 10 to the fourth power is an easier way to say it, right? Well, what does 10 to the second mean? Well, that means 10 times 10. I bet you Alan could have told us that. Now, Seth could definitely tell us. I've got 1, 2, 3, 4, 5, 6 tens being multiplied together. The easy way of saying that is 10 to the sixth power. You understand? So there's 4 tens here, and there's 2 tens there. Now, some of you guys are so smart, I'll bet you notice that you could just do 4 plus 2 and get 10 to the sixth, and you're absolutely right. Here, you try one really quick. Let's try 10 to the fifth times 10 to the, let's make it 8. All right, you go ahead and try it on your own. And if you think you can do it, go ahead and pause the video. And when you're ready to see my solution, go ahead and unpause the video. All right, here comes my solution. Now, I know the long way of doing this is that 10 to the fifth means this. Right? There's 5 tens being multiplied together. And then 10 to the eighth means this. Oh my gosh, I'm getting tired of writing this, Mr. Lawrence. This is too much work. I know it's too much work. 1, 2, 3, 4, 5, 6. All right. And so all together, I could count up all the tens. But I know what's going to happen. I'm going to have 5 tens here. I'm going to have 8 more tens there. 5 plus 8 is 13. This is the same as 10 to the 13th power. Watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There you go. 10 to the 13th instead of saying 10 times 10 times 10 all those times. All right, so let's go on to the problem. Now that you know how to do that, multiplying and dividing scientific notation is going to be pretty easy. I'm going to do the quantity of 2 times 10 to the third times the quantity of 3 times 10 to the fifth. And here's what I'm going to do. I'm going to multiply the 2 and the 3 together. Oh, that's a hard one. Let me get a calculator. And now I'm going to multiply 10 to the third times 10 to the fifth. Well, I know that I'm allowed to add those exponents. And so that will become 3 plus 5 is 8. So I'm in scientific notation because my number here is between 1.00 and 9.99, right? 6 is between those two numbers, and I'm times 10 to a power. So this is my answer. By the way, why don't you go ahead and convert that to standard notation? If I do 6 times 10, I'm going to get 60. 6 times 10 squared would be 100, etc., etc. So I'm going to find my decimal point, and I'm going to move it 8 places right. So 1, 2, 3, 4, 5, 6, 7, 8. And so I'm going to fill in zeros. And my number will end up being, oh, silly, 600 million. There it is. Okay, let's try this one. I'm going to multiply 8 and 1/10 by 6. That's easy. 6 times 1 is 6. 6 times 8 is 48. And there's 1 digit after the decimal point. So I put the decimal point so there's 1 digit after it. I multiply by 10 to a power. I've got 6. I've got 2. 6 plus 2 is 8. The only problem is, look at this answer. This answer should bug you. It's not in scientific notation. the decimal point is not after the first non-zero number. So I am going to need to divide this 48.6 by 10. If I divide it by 10, that will move the decimal point there. So my new number will be 4.86. Oops. All right. Times 10. But if I divide this guy by 10, he got smaller, right? This exponent will have to be multiplied by 10 and get larger, right? When the decimal gets smaller, the exponent has to get larger. Otherwise, they're not equal anymore. Okay, so don't worry, we're going to get some practice with this in class tomorrow. So, here we go. We are going to divide now. And it's very similar. I'm going to divide 240 by 6. And I know 6 goes into 24 4 times, so it goes into 240 40 times. It's going to be times 10 to a power. But hold on a second. It's not going to be the 13th power. When I'm multiplying, I added the exponents, right? But when I divide, I'm going to subtract the exponents. I'm going to do 8 minus 5, and it'll be third power. Okay? 40 times 10 to the third power. So that was when I multiply. In scientific notation, I add the exponents. But when I divide in scientific notation, I subtract. It kind of makes sense. Multiplication and addition go together, and division and subtraction go together. They're inverses. All right, so now, I don't like my answer. What don't I like about it? What's that? What's that, Faith? Yeah, you're right. The decimal point is not in the right place. Currently, the decimal point is after the 0 in 40. I always want the decimal point to be after the first non-zero number. So I am going to have to divide by 10, changing the 40 into 4.0. But if I want to keep the number the same, just change the way it looks. If I divide this by 10, divide by 10, here I have to multiply by 10, and that will change 3 to a 4. And there you go. There's the answer in scientific notation. All right, one more example for you. And then, like I said, Monday we'll get some practice in class. All right, 33 divided by 3 is going to end up being 11. 10 to the second minus, or divided by 10 to the sixth. Remember, when I'm dividing, I subtract exponents. And 2 minus 6 equals negative 4. This will be to the negative 4th power. One more time, I don't like my answer. My decimal point is in the wrong place. It's currently here. I need it here. I'm going to divide 11 by 10 and get 1 and 1/10. All right, which means I have to multiply by 10 over here. I divided by 10 on the decimal. I have to multiply by 10 on the exponent. So negative 4 plus 1 is negative 3. And there you go. It's as easy as pie. All right, that's it for tonight. We'll get some practice on Monday. Good night, everybody.